Okay, so the last section in chapter 6, we're doing differential equations, growth and decay models. So we're going to be solving differential equations specifically for growth and decay. Okay, so solve the differential equation. So I need to get it back. So I multiply both sides by y. So I have y prime equals 2x. So then I integrate both sides.
Okay.
Well, I should have a dx here, shouldn't I? So if I have y prime dx, that just gives me the integral of y equals the integral of 2x dx. So here, this would be 1/2 y squared. Yes. And the other one would be 1/2 times 2, so it would just be x squared. Plus c. Now, there's a c on both sides, yes. But if I subtract it over, it's still going to be some c either way. So I just put 1. But technically, there is 1 on each side. So I'm still solving for c. Well, they leave it like this. No, they don't. Okay, they set it equal to c. Sorry. So if I set this equal to c... Well, first of all, this 1/2, I'd multiply everything by 2. Yes? So I have y squared equals 2x squared, and 2 times c is still c. And they set it equal to c on all of them. So your general solution is c equals y squared minus 2x squared. And again, this is a GS, standing for general solution.
Golden State.
Yes, probably not.
Good sound.
So, want to do it again?
Yeah.
Okay. So, dy dx just means y prime, right? So there's no y to multiply over. So we just have the integral of y prime dx equals the integral of x plus 3. So the left-hand side... Wait a second. Oh, I did that wrong. Because should I multiply over by the dx? Sorry. It should be that, shouldn't it? I can't just discredit it, can I? Unfortunately. And then now would I integrate both sides? So the integral of dy would just be y. And then what I'd have 1/2 x squared plus 3x plus c. Can I multiply everything by 2 to get rid of the fraction? Okay. And again, you don't have to. It just makes it look better. And if we're doing general solutions, you shouldn't have any fractions in it anyway. Okay, so then that gives me 2y equals x squared plus 6x plus c. So c equals 2y minus x squared minus 6x. And that again is a GDS, which is a general solution. You guys good with those? Okay. Okay, so the growth model. In applications, the rate of change of a variable y is proportional to the value of y. So if y is a function of time, the proportion can be written as shown. So dy over dt, so the change in y over the change of time, is equal to k y. And k is your constant, your proportional constant. Okay, your rate of change. That. So your exponential growth model is y equals c e to the kt. Does that seem familiar from last year?
You probably would.
It was PERT, wasn't it? Principal.
Yeah, except now
It's just c and k. So we had y equals p e to the rt last year, where p was the initial amount, right? So that means c is your initial value, e is e, r was rate, but now we have it as a k. Does it change what it is? No. They say k is the proportionality constant. Well, that's still a rate, isn't it? A proportion is a rate, and time is time. K has to be less than 0. We don't do proportionality. Well, okay, if K is greater than 0, it's growth. If K is less than 0, it is decay. So if y is a differential equation, the function of t such that y is greater than 0, y prime equals ky. For some constant k, then y equals c e to the kt. So those are the equations that we're using. So you're going to be doing growth and decay models. So you need to find the original rate. So y is the ending amount, correct? If c is the initial, y is the ending, r is the rate, and t is the time. So those are 4 variables. As long as you have 3 of them, can you find the other ones?
Yeah.
Yes. Let me know when you're done. When you're ready. Okay. Come on. Okay, using an exponential growth model, the rate of change of y is proportional to y. When t is 0, y equals 2. When t is 2, y equals 4. What is y when t equals 3? So the model we're using again. Why does it keep jumping?
I don't know.
Okay, so the model we're using is y equals c e to the rt. Correct? So when we have t is 0, we have y. When we have, okay, so we don't know r or c, do we? No. But we have two variables and 2 unknown variables, so can we do a system of equations, that kind of stuff? So I know 2 equals c e to the r times 0. And I know 4 equals c e r times 2. So, well, this first equation, if it's times 0, so r times 0 is 0, e to the 0 is 1, so c equals what? 2. That helps me out, right? So now I have 4 equals 2 e to the 2r. So can I solve for r?
So how?
Well, hopefully not too hard. How would I solve that for R?
With
Divide by 2. So 2 equals e to the 2r. Natural log of both sides, right? So that's going to be the natural log of 2 equals the natural log of e to the 2r. So the natural log of 2 equals what? 2r. So r equals
natural log of 2 over 2.
natural log of 2 over 2. So now that I have r and I have c, we're going to write our general solution. So that would be y equals c, which is 2, e to the r times t. So that would be natural log of 2. I'm going to put t in front of the natural log of 2 over 2. So there's my general solution. So how am I going to find what is y when t is 3?
Well, then you put in 3 for TE.
So y equals 2e to the 3 natural log of 2 divided by 2.
Yeah.
And then you would use a
A calculator.
calculator.
I don't have.
Should be approximately 5.657. If the book's right. And is this a growth or decay model, guys?
Since
It's growth because r is greater than 1.
yeah, well, since it's greater than 0, that's what our thing said. Greater than 0.
Oh, yeah, greater than 0. Yep. And I probably should have put that r as a k, but I cannot.
Throwing me off and I was trying to
I'm
figure out
sorry.
what was or the exponential.
Is it still an r, even though it's a k?
It is, I just
I know. That was my fault. Sorry. Autumn's checking me.
I believe it.
Okay. So, radioactive decay is measured in terms of half-life. You guys have heard the half-life of chemicals, correct?
Yeah.
This is on page 417. You may need it in your application, okay? If it talks about uranium, plutonium, carbon 14C, radium 226, all that, okay? So it takes 4,470,000,000 years for uranium to reach half. Okay? You all understand what half-life of a chemical means, correct?
Yeah.
Okay, so noblium, is that how you say that? Takes 25 seconds. That's pretty good, right? Uranium,
Good Nobel.
not so good. So, considering they're all radioactive, I don't know if we want to be hanging around any of them, but
I don't mind hanging around carbon.
mm,
I'm forced to.
radioactive ones, I don't think I want to be hanging around. Not for the next 6,000 years, just to be half. Okay, so those are some things that you might need to know. Okay, so half-life means they're going to have half left, yes?
Yeah.
Okay, so the reason why I keep bringing that up is somebody will tell me, well, Mrs. Mick, they didn't tell me how much is initially there. It doesn't matter because when you have the initial and the ending amount, when you take the ending divided by initial, you're always going to get what? Half? Because it's half-life. Get what I'm saying? So when you deal with the half-life, you don't have to, when you have your y equals c e to the kt, we divided over by c first, didn't we? So y over c is always going to equal what? A half. So a half would equal e to the kt. So if you remember that, it makes your life a little easier. Trying to think about if I need to keep going with this stuff. All of this stuff is tomorrow. Do you want to keep going or do you want to just do notes tomorrow?
I won't be.
You won't be here. We'll keep going.
Keep trudging.
Okay. So suppose that you have 10 grams of plutonium isotope 239 Pu was released in the Chernobyl nuclear accident. How long will it take for that 10 grams to decay to 1 gram?
Well, let's go back to the other side so we can see how long it takes.
The half-life for that is 24,100 years.
24,100 years.
So that's the half-life. It's a little bit, isn't it?
To us, not to geological time.
So, again, we're still using CE to the KT. So, we don't know the rate at which it decays, do we? Which we need to know because we want to know how long it's going to take to get to what? 1 gram. So, once we know that rate, we can take a look at it. Well, the only thing we do know is what? Half-life? So, what's half of 10? 5. So we know that 5 equals 10 E to the K times 24,100. So I need to solve that for K. So again, if I would have thought about it, 5 divided by 10 is what? 1/2. So 1/2 equals E to the 24,100 K. And then I take the natural log of both sides. So the natural log of 1/2 equals, I'm just going to skip to 24,100 K. Y'all good with that? So then K equals the natural log of 1/2 divided by 24,100. So I want to know when I get to 1 gram. So 1 equals 10. E. We're looking for T, correct?
Yeah.
So it's going to be T natural log of 1/2 over 24,100. So what do I need to do to solve that?
Well, do some stuff and then put it in the calculator.
Divide by 10.
That's a good first step, yeah.
So 1/10 equals E to the T of natural log of 1/2 divided by 24,100. Take the natural log both sides. So the natural log of 1/10 equals T, the natural log of 1/2 over 24,100. So then I'm going to multiply by the reciprocal. So T equals 24,100 natural log of 1/10 divided by the natural log of 1 over 2.
Well, it seems like a long time. I'd say at least like a couple years.
Well, let's see. Just a couple?
If I had to guess,
What's your guess?
um, $90,000 years.
It should be 80,059.
Yeah, that was close.
Is that what you got, Autumn?
Mhm.
So considering 90 to 80 is pretty close because 80,000 years. So that's a long time, isn't it? I'm like, you think of it, 10 grams is like nothing. And
I
so
don't
when they
know, I
had,
think, wait, what's a gram in American? That's not what I
gram's not very much weight.
think. No, it's not.
Like, I don't know.
About
Like,
1/30th of an ounce. I think. It's like 30 grams in an ounce. But I also don't really know how much an ounce is.
grams. Okay, so a penny is 2.5 grams. So 4 pennies
4 pennies to a little.
will be
under.
less than a half of a penny.
Yeah.
But 4 pennies, that's not a whole lot. That's just in weight. I mean, I don't know how much that weight,
Yeah.
But I figured let's put it in something that we can think about. That's not very much, is it? It's kind of scary when you think about like accidents on that train and all that stuff that fell and how long it's going to take that stuff to go away. We'll be glowing in no time. Okay, suppose an experimental population of fruit flies increases according to the law of exponential growth. So as soon as you see that, what equation should be thinking?
Kect.
Okay, I'm going pert, but okay. There are 100 flies after the second day. So, 100? 2 days for time, right?
Yeah, it would be like that.
And 300 flies after the fourth.
Mm-hmm.
So 300. Approximately how many flies were in the original population? So we need to know what C is. So how are we going to do that?
I just start plugging stuff in.
Start plugging stuff in. So we know we have 100 equals C E to the 2T, right?
Could be
Because 2 100.
2 our time.
Yeah. Oh, 2K.
Yeah.
Sorry. And then our other one would be
300.
300 C
at 4K.
E to the 4K.
Yeah.
So we have 2 equations and 2 unknowns, so we have to pick one to throw in there, right? Well, if we want, would solving for K be feasible? So you divide by C, right? Well, to me, I want to solve for K because then I could set them equal each other. So do you guys want to do elimination or substitution? I guess is my question.
Substitution.
So do you want to solve one for C and plug it into the other, or do you want to solve them both for K and then just equal to each other?
I don't know.
Probably solve for K.
Solve for K?
Each other.
Okay, so that we divide by C. And then we're going to have to take the whole natural log thing, right? So we'd have the natural log.
What's your C is 6?
Oh, I don't know.
It's a goofy looking C.
Over 100C
Mm-hmm.
divided by 2.
Equals K. Well, it doesn't equal anything yet because we'll just put the other side. Okay.
And then, actually,
Natural log of 300 over C equals over natural log of 300 over C over 4.
so it'd be the natural log of 300 over C divided by 4 equals K. So they now equal.
Each other.
So this would be 4 natural log of 100 over C equals 2. Actually, can I just,
You can just make.
can I multiply by 4 and then make it 2? Okay. Yeah, why would we move that twice, right? So 2, and then the natural log of 300. Well, this 2 would become an exponent, wouldn't it?
The whole thing, yeah.
So how do I get it?
Change it back to base E.
Well, could I subtract? I'm going to subtract it over. Right? So then it would equal 0, wouldn't it?
Yeah.
So the subtraction would be division. I'm running out of room.
You write it with a lot of space behind it.
But there's a lot of stuff there. So 0 equals the natural log of 300 over C over 100. Actually, can I just put 10,000
Because it's, yeah.
over C squared? So then I'd multiply by the reciprocal, wouldn't I?
Okay.
So it'd be C squared over 10,000.
Three.
So it'd be natural log. So 2 zeros would cross out. And 1C.
Over 100.
So 3C over 100.
Yeah.
Not 100. Yeah.
Yeah.
And it equals 0. So now I need to put it into exponential.
Yeah.
So e to the 0.
Equals.
Because I do here and here. So this would just be 3C over 100, right?
You have 1 equals.
So then I have 1 times 100.
100 over 3 equals C.
Can I just do 100 equals 3C?
Yeah, but
Yeah. Because you'd multiply 1 by 100.
yeah.
So C
That's
equals
what
100
is that
divided by 3.
100 over 3 equals C.
Oh, I didn't hear you say that. Sorry.
That's why I was confused. We're going back. We're going backwards.
So we have C now.
We have C.
So what do we need to... Oh, that's the original.
Yeah.
So how many is that?
We had approximately 33 flies.
Because we can't have like 0.333 of one, can we?
No, we can't.
Probably have flies as a title. So we went into logarithmic, out of logarithmic. You're going to have to be going back and forth, right? You just plug it in and keep looking. Now, could we have done it other ways? Yes. I think we did probably a longer way, but we didn't have to solve and then plug it back in because we just kept solving. I personally would rather do that. That's up to you. Questions? That's all I got.